Today on Listen Up, getting back to the Big Bang. Science seeks to discover the mystery of how the universe began. Will they do it? That's next. Welcome to Listen Up. I'm Lorna Dewitt. Take 8,000 scientists, add $10 billion, throw in natural curiosity, our never-ending quest to explore boundaries, push limits, and solve the world's mysteries. What have you got? The search for the God particle, the latest effort in science to understand how the universe began. It's called the Large Hadron Collider, or LHC, a 27-kilometer-long circular research lab designed to crack the code of the physical world, to figure out how the universe came into being. Today, we're exploring that same question from our Christian worldview. We'll visit Dr. Robert Orr, a particle physicist at the University of Toronto, to learn about Canada's involvement in the world's biggest science experiment. We'll also speak with John Polkinghorne, a particle physicist and Anglican priest, for his thoughts on the LHC and whether science and faith in God are compatible. But first, the LHC is buried deep under Franco-Swiss soil at the European Organization for Nuclear Research, or CERN. Scientists there plan to fire subatomic particles around the long looping tunnel until they crash into one another at close to light speed, breaking into even tinier particles. They hope to find something physicists postulate but have never seen, called the Higgs boson, or the God particle. The discovery of how matter becomes energy, how the universe ignited into life. When the LHC was switched on, there was concern that it could set off a doomsday scenario by creating a black hole that literally devours the Earth. Just 9 days after science's biggest experiment fired up, technical problems shut it down. Scientists hope to have it working again in the spring. Could this experiment help to explain our universe? Ricky Ratliff met with the University of Toronto's lead physicist in the experiment, Dr. Robert Orr, to find out more.
So what this is supposed to represent the quantum mechanical process of an electron emitting what's called a virtual photon, which hits a quark inside a proton and makes it decay.
No, it's not Greek. What it is particle physics, the study of subatomic matter and energy and the interactions between them. It's from here, in the Department of Physics at the University of Toronto, that Dr. Robert Orr has led Canada's contribution to the LHC. His team works with ATLAS, a specially built detector that's designed to find any new particles created when protons collide.
So what the LHC is, it's almost like a nuclear weapon in reverse. We accelerate the protons up to very, very high energies. And just as in, for example, a nuclear weapon, you can convert the massive uranium atoms into energy, what we do is we convert the energy of the beams of protons into the masses of new particles, very massive particles that haven't existed since very shortly after the Big Bang. That's why people talk about recreating the conditions just after the Big Bang. So that's what the LHC and the experiments around it are designed to do. They're designed to take protons up to very high energy and convert that energy into the masses of particles that we haven't seen before and that may or may not exist. So it's an experiment. We'll see whether they're there or not.
Some physicists jokingly refer to the Higgs boson particle as the God particle. Why is that?
It's a very important part of what's called the Standard Model, the Higgs boson, because we couldn't understand why particles have mass unless this particle exists.
Scientists say that if they don't find the Higgs, they might find something else that plays the same sort of vital role.
This is one way that you could produce a Higgs boson. This is a proton from one ring in the LHC. This is a proton from another ring, and they emit these two things called W bosons, which coalesce into a Higgs.
Dr. Orr, at a $12 billion price range, this is quite the pricey experiment.
Well, compared with $700 billion to bail out the US economy, it's not much, is it? But yes, and in fact it's spread over the whole world, but probably the accelerator cost about $10 billion since 1994. And the experiment we work on probably cost about 500 million.
Dr. Orr doesn't work alone, of course. And while his passion for his work may be somewhat understated, some of his colleagues are quick to voice their enthusiasm for all the potential the LHC experiments hold.
The LHC, I think, is really important. It's the first new machine that's being built in years, and it's looking at a whole new regime where we have never looked at before. So I'm hopeful because theoretical physics hasn't really moved on very much in the last 30 years. So I'm really hoping that this machine will show something new.
Are you excited about this?
Of course.
Why?
Well, because LHC has like 10 times more energy than the previous experiments that are in the Fermilab. So we bet for sure that we will find something there.
Why is it so important?
Well, why is it so important? It depends who you are, how important you think it is. To people like me, it's very important because what we've been trying to do, or not me personally, but the people before me, for centuries is to understand what matter is. And now we realise that matter and space-time are in some way very intimately related. So what we're trying to do is understand the real basis of reality. What is reality? What is matter? What is space-time?
Of course, there will be practical implications as well. It's thanks to the past discoveries of physics that we have everything from microphones and microwaves to iPods and iPhones today. What do you say to the skeptic physicists who believe that you guys are stepping into unknown and scary territory messing with high fields of energy? What do you say to those skeptics that believe that we could possibly create a black hole with this project and have the world just cave in on itself?
If somebody says to me, you can produce black holes that will destroy the Earth, I say to them, you're overestimating our abilities, actually. We're not that powerful. The LHC is actually a quite low energy machine compared with what goes on around the Earth all the time.
Dr. Orr, should we place limits on science and the exploration of the unknown?
I think there are things that happen in science that you should, society through its elected representatives should think very carefully about whether you want to do these things. For example, there are many things in the life sciences that you could say to yourself, I'm not an expert in life sciences, but I know things like recombinant DNA, stem cell research, stuff like that, represent big moral problems, and they represent big problems for the future of humanity. If we start to manipulate our genetic code and stuff like that, do we actually remain human? So there are areas that once you know something, you say, I shouldn't apply this.
But as for the LHC, Dr. Orr and his colleagues are comfortable and confident in their science. And if they find that God particle they're searching for, what then? Well, plans are already underway for a new accelerator, one that would be built to study the properties of the particle in detail. It will be called the International Linear Collider.
We talk about starting work on that maybe 10 or 15 years from now, so we're already designing it.
Reporting for Listen Up, I'm Ricky Ratliff.
When we come back, we'll speak with a world-renowned physicist who is also a priest to ask if there's room for God in the quest for the God particle. But first, the scientists at CERN have come up with a clever way to help us understand their work, YouTube style. Take a look.
27 kilometers of tunnel underground, designed with mind to send protons around. A circle that crosses through Switzerland and France. 60 nations contribute to scientific advance. 2 billion of protons being round through the ring they ride, till in the hearts of the detectors that made it collide, and all the energy packed in such a tiny bit of room becomes mass particles created from the vacuum, and then.
Oh yeah.